So I would like to explain again. I would like to try a little bit harder. Okay, here. My portable Dyson spheres. Okay, if the U.S. government can help me, or the Department of Interior, whomever, there's got to be a way to make those levitate. I'm interested in magnons, or what was it? Magnons, or I think it was magnons. I'll have to look at that. I'll have to go read that paper again. I'm interested in it. I'm really fascinated by that. I really need to read that. Um, I want my spheres to fly. Okay, and I'm going to release a little bit more information about them. So what I'm doing is I'm kind of telling a little bit more here and there. Okay, I've got plans. I've got ideas. I've got ideas to secure my property. Okay, my intellectual property. This is mine. It's not yours. It doesn't belong to you. It's mine. I'm going to make sure it stays that way. I think I've almost pretty much already done that. So, if you think about it, just think about fusion energy. Think about the energy that is created. Think about the energy that's consumed and the energy that's created. Okay, so we're trying to put out more fusion energy. You know, right? We're trying to put out more energy than I forgot the term for it. I'll look it up. I should know this. A guy like me should know this, but it'll come to me later. But it's sort of like power factor. So, when a quantum computer is directed to open micro wormholes in my second Dyson sphere, that will feed back into the first reactor. The first reactor has to be engineered and designed in a way that it can receive more energy and be exponentiated, shielded with diamond. Both of these have to be shielded with diamond. Okay, thick diamond. Because the first one's going to be magnetic confined fusion energy as a reactor. Now, when those micro wormholes are being opened, if you just think about it like this, okay, let's say we're feeding on a, let's say you're feeding on something that's, let's say here we've got, let's say here's energy being consumed, right? Okay. You move it down here, in time space, this energy can be consumed too. It's still very real matter in the past, but it creates energy infinitely. Matter. So essentially matter and energy are created infinitely. Matter and energy are infinite throughout space-time. So, in this sense, as the quantum computer is opening these micro wormholes and having them directed, see, the system is meant to not just regulate energy, okay? So, it's not just about energy regulation, okay? It's about energy regulation, targeting, and directing. So once you have that feedback loop going on, you can then use the quantum computer to open one direct, larger, maintain a larger open wormhole. And only a quantum computer can perform the necessary calculation to target what I am going to call specific anti-frequency to not just open the wormhole, but to open a direct point, a location in space-time, and a certain date, certain time. My little drawing there made it look scary when I wrote 1942, you know, 2036, you know, my little man going back and forth between those times. I was just thinking about how it could be possible, okay? I don't want to go back and start the Battle of Los Angeles. Excuse me. But anyway, you're thinking about, you know, finding the axion, okay, evidence of dark matter. I don't think that's going to work right now with our current technology. Um, and I don't think we're going about it the right way because the axion is always going to be as it's always going to be it's always going to be evasive at a reach. You know, it's really not possible to catch. Here's the secret. It's not possible to find it without opening or without observing the opening of a wormhole. I don't believe. But what you can do is you can observe its impact on space-time, just like you can do with gravitational lensing. Okay, so you can see out there what you've been looking at, right? That cohesive state, in a sense that it looks like there's something holding it all together, right? Dark matter, you know, changing the way things are orbiting or having some sort of influence or some sort of impact. Think J.J. Thomson's charge to mass ratio, okay? So think about that experiment with the, was it cathode ray tube? Cathode ray gun. No, it was in a tube, do you believe, yeah. I need to reread the experiment, see. But we want to perform an experiment, something like that, okay? Now, once we have that information, we're going to be able to use a quantum computer to look for certain signatures, like that impact. We're going to be able to find an equation. We're going to be able to find whatever. I've got more math to go. You know, right now I see it in my head as a potential logarithm. I don't know, I'm probably wrong there, but there's a lot of math I need to learn, you guys. There's a lot. You know, my math, I'm about ready to enter trigonometry. Okay, so here's what I'm saying. Okay. I see it as like a bowling ball on a sheet, okay? Okay. So we see matter that way right now, right? We see matter's impact, okay? Well, dark energy is also going to have a very similar thing, except we're going to be looking for the anti-frequency. We're going to be looking for something different. We're going to be looking for that very large impacts anti-frequency, okay? A quantum computer is going to be able to tell us that signature. And once we look at the constellation of Orion, let's say we trigger, let's say we find a very specific target point, okay? That's going to have its own anti-frequency. We can then extrapolate back out, like a logarithm, kind of, you see what I'm saying? To a base factor, where we have an equation. We have something that's going to tell us, hey, this anti-frequency is for constellation Orion. This is for Capricorn. Here's for, and then we can get closer and closer and closer and closer until the quantum computer tells us the exact information that we need to know to target location. In so doing, we target time space. And let's say we want to go back to Earth. Let's go to the moon. We step further back. Let's say we've got those numbers now. We can get that anti-frequency for 12 p.m. a light year ago. And for current now. The quantum computer is going to be able to hold those values to bring us back to the exact same date, time, and place when we open my wormholes with my portable Dyson spheres. Okay? We're going to need the third one for transportation. The first two are going to be able to maintain those wormholes, and these two, they're going to have a quantum computer type, like kind of like a Cartesian coordinate system, grid system, for guidance. And these spheres can kind of look out for each other, right? And perform navigational measures together. And that's it. Partly. That was the quick version.